My name is Alyssa Swanson, and I am an Associate Director of Global Programs and Lifelong Learning in Alumni Relations. Today, we welcome two guests. Sarah Toms, co-founder and Executive Director of Wharton Interactive, who will share opening remarks and moderate Q&A, as well as Raghu Iyengar, Professor of Marketing and Faculty Director of Wharton Customer Analytics, who will share a presentation on machine learning and marketing analytics. Sarah and Raghu will save time at the end of the session for Q&A, so we hope you will use the Ask a Question button found on the top of the video player to submit questions at any time. Now please join me in welcoming Sarah.
Hello, everybody. It's really lovely to be here with you today. As Alyssa mentioned, I lead Wharton Interactive with Professor Ethan Mollick. It's an exciting new initiative where we are building entire Wharton courses in hyper-immersive games. And we call these games alternate reality courses. It's one thing to sit and passively hear a lesson, and so much better if you can actually roll up your sleeves and experience it. This is how we actually build lasting skills and expertise. So let me talk about the star of the show. Raghu Iyengar, as Alyssa said, is Wharton Professor of Marketing and Faculty Director of Wharton Customer Analytics, the world's preeminent academic research center focusing on the practice of data-driven business decision-making. We've designed a two-part webinar series for you. Today, part one, Professor Iyengar is going to delve into how machine learning is transforming the field of marketing analytics. And after his presentation, you will have ample opportunities to ask him questions. And then I'm going to do a bit of setup and explanation for part two of this series in the last 5 minutes that we have together. So spoiler alert, Raghu is our most recent faculty author to launch a highly interactive game on Wharton Interactive that walks you through the fundamentals of machine learning. And we're going to have an opportunity for you to experience that game and then come back in part two, and we're going to talk about it together. So without further ado, the star of the show, Professor Iyengar, over to you.
Thank you. Thank you so much, Sarah. Very kind introduction. I hope I live up to it. We'll see. So I'm going to share my screen and start the discussion. So welcome, everybody. As Sarah mentioned, I'm Raghu Iyengar. I'm a professor in the marketing department. I'm also the director of Wharton Customer Analytics, which is a research center that does a lot of work around analytics. Please do check it out. Just Google Wharton Customer Analytics and you'll find me and the center. So what I wanted to do today is, in the time that we have, talk a lot about marketing analytics and machine learning by giving some examples. And please ask me questions, as was mentioned. My goal here is to have as interactive a discussion as possible, so we'll have time for Q&A later. So let's get started. When you think about machine learning, when you think about all the investments that companies have been making around big data and all of that, many companies come to mind. Let's take a popular example, Disney. Now, some of us who've made the pilgrimage to Disney, perhaps, or at least have seen some of these new things that Disney had been investing in, they may be aware of something called the Magic Band. That's what this person is wearing. What's the Magic Band? The Magic Band basically is a way in which Disney can collect a lot of information. And so if you look at some of the typical kind of stories that come around, it talks about how Disney has made a huge investment in Internet of Things. It talks about big data, IoT, machine learning, all kinds of stuff to boost customer experience. Now, what does this Magic Band do? All kinds of capabilities. It's basically this device. Think of it just like the strap that you have, which is what is being shown in the picture. You can enter the park, lock hotel rooms, get all kinds of priority access to different kinds of experiences, all of those wonderful things. Now, the first thing which I've seen many companies do, and you may recognize your company as one of them, or perhaps other companies you've had experience with, is that they start looking at some of these examples and say, wow, this is amazing. I mean, there are all these wonderful things that Disney is doing. So the first thing that people say typically is, we can do it too. Let's try to emulate what's going on. And you start thinking about how can we do it? Perhaps, you may have an engineering kind of mindset to sort of say, well, what is the data engineering kind of layout that we need to have, which will get this to happen. So it could be in terms of what our data sets are, what is the talent we need to hire, all of those are important questions. I don't kind of disagree with that at all. But I think what is more important, more fundamental than that, are perhaps two questions that sometimes get lost in all the details, which are why and so what. I think when you think about all the investments that are happening around machine learning, AI, big data, all of those things that are going on, not just in the US, in every part of the world. I've interacted with lots of Indian companies, for example. When you hear about all of that, they talk a lot about how they're creating the next data mesh, the data lake, whatever the case might be. I think, yes, those are important. But I think before we get into that, the question which is perhaps more important is, why are we doing it? What particular business question is being asked? And then, why do we care about this? Importantly, who will make a better decision? And it doesn't always have to be customer facing. It can be internal as well. But at the end of the day, you have to answer the why and the so what before we perhaps answer the how. So let's go back to the Disney, the why and the so what. Now, in the case of Disney, you might say perhaps operations might really like the fact that we're getting all this information, where people are in the resorts, because that particular band can kind of literally tell you where people are moving through the resort. So the traffic flow through the resorts might be helpful for operations. Why? Because then they can start deciding upon resource allocation. That's one of them. Marketing. Now, obviously, as customers go through the resort and take different rides, they can then start thinking about, they meaning Disney, and then start thinking about the level of personalization that can be done. So for those of us who perhaps have gone to Disney and taken one of these magic bands, you can put a lot of information in there before you take the trip. So if I'm a marketing manager at Disney, I might be able to take that information and perhaps personalize your visit. If you think about innovation, again, looking at all the information, what rides you take, what rides are popular, what rides you're willing to wait for a while for, all of those are great ways to develop new products. Put differently, if you think about the overall structure, why is this investment for Disney perhaps, again, big data, IoT, machine learning, AI, why is this helpful is because it helps them understand the needs of their stakeholders. So I think one thing that I would like to kind of talk about as we go forward, is there value in AI and ML for making better decisions? I'll give you many examples. It can be. But what I don't want you to do is kind of think about the data lake or the data mesh, the data warehouse, wherever you are. That's not the magic bullet. And many times when I talk to companies, I tell them that as soon as they're thinking of it in that way, press the SOS button. What is SOS? SOS is shiny object syndrome, which is you want to just make sure that you're not embracing ML and AI for the sake of embracing it. I don't think it's enough to say, well, we need to put investments. Why? Because something will happen in the future. I think you need to be problem driven. So what I'm going to talk about today as we go forward is, what are some examples of companies that they have become problem driven? What are some things that are worth emulating? What are some pitfalls that we should be aware of? Yeah, so as we keep going forward, we'll take some examples. And of course, as I said, please, if you have questions, comments, anything of that kind, we'll have enough time in the end as well to have that discussion. So the question, of course, before we dive into the specifics of machine learning, is how best to get ROI, return of investment, from analytics. Well, I think the first big takeaway I have seen, again, having the privilege of being the faculty director of Wharton Customer Analytics, we talk to a lot of different companies. I think what I've seen many companies who've gotten good ROI from analytics do is not leaving analytics only to the quants. I think there has been remarkable revolution, and Sarah will talk a little bit about that as well, given all the Wharton Interactive and all the different things that they're doing. But do not leave analytics to the quants. What does that mean? I think we should now be in a position where the C-suite, the decision makers, kind of work hand in hand with the people kind of quote unquote running the models to identify the key business problems. Many times you may have seen that you hire great talent in terms of data scientists or data engineers, as the case might be, and they are great at what they do. They love connecting quote unquote data sockets, data engineers, or they love solving problems. But I think the big issue is kind of the so what. making sure that you as a decision maker are leading the way in terms of making sure that the key business problems are clear. And of course, at the same time, any company that is having this digital revolution, analytics revolution, as the case might be, I think you have to lead the change in the mindset. As you can imagine, in many, many organizations, there is the hippo syndrome, highest paid person's opinion. And to kind of go from that culture to a data-driven culture using machine learning, AI, big data, it takes a lot of time. So understanding that the transformation takes time and it's a journey becomes quite important. And finally, I think when you think about kind of the type of analytics, type of projects that have become quite successful, and type of transformations that actually bring about change, those are ones where there is careful planning. I think the hope and wait, pray and pray, and all those approaches, yes, they may work in a while, but I think the best approach are ones where you're carefully thinking about the business problem, answering the so what, and planning out the implementation. So having said that, now let's start thinking a little bit about, demonstrating the impact per se. Now, this is a wonderful survey that's done by a colleague down in Duke University. She is Chris Moorman. She's a marketing professor there, and she does the CMO survey. I've chosen February 2020 just as the date where I kind of took this particular piece of data, just because COVID kind of came into the US at least around March. That's what everyone says. So I just wanted to make sure that we kind of look at pre-COVID, kind of see what the situation was there. Obviously, after that, there was some turbulence. What's the big picture I want you to take away from this? The big picture I want you to take away from this is only 35% of companies have proven the impact quantitatively of their analytics. And that's not good enough. I think one thing we have to be very careful about is that all those investments, all the wonderful things that we have been doing in machine learning, which I'll talk a lot about as well, I think we want to make sure that we track things properly. We want to make sure that it's quite clear how exactly would success be defined. So what I want you to do is, as I give you more examples, just reflect in the back of your mind, and would love it if you want to share some information towards the end when we have the Q&A, is if you reflect some analytics initiatives within your company, could be recent, could be in the past as well, or perhaps in other companies that you were at, were the why and the so what discussed? Was success predefined? Exactly how you're going to measure success? And what were the hurdles in the organization as you went through that transformation? I think keeping that in mind is very helpful as you start thinking about whether investments in machine learning and AI are worthwhile for your company. I think they would be, provided the right infrastructure is around them. And B, when you start thinking about the decisions that will be made differently, that brings a really clear actionability mindset as you think about machine learning. Now, having said that, let's get into it. What is machine learning? There are many different ways in which one can define machine learning. One popular way of thinking about it, it's the practice of either detecting data patterns, it's the practice of parsing data itself, it's developing algorithms for better prediction or categorization. So I'll give you many examples. Now, the typical goal of machine learning, just to make sure we're all on the same page, is better prediction. It's not causality typically. Why? Because there are so many things going on within the machine learning module that it's like a black box. I think it's great for kinds of decisions where all you care about is prediction. And there are many of those. You might care about better sales forecasts. You might care about recommendation systems. But if you start kind of thinking about the why part of it, which is why did this happen, that's where there is a little bit of hesitation in machine learning models because it's much harder to describe the why. And I'll give you an example as we go forward. So what are the typical steps? Typical steps are quite similar in spirit to any statistical model per se. Machine is given an algorithm, you get some existing data sets. These are what are called the training data. And then you use this training data to come up with a model. And then the model is quote unquote tested using a test data set. Okay? So training and test are the typical terminology that is used. Training data is basically the data you're using for calibrating the model or quote unquote training the model. The test data is the data that you're using for testing the model. So I think the names are quite self-explanatory. So that's exactly how they are used. Now, there are many areas in which machine learning has had a lot of success. Forecasting, recommendation, segmentation, targeting, dynamic pricing. And I think the list keeps going on and on. I think what you have to think about as you think about machine learning and all the different decisions that you might be making within your organization, how relevant is it? It doesn't need to go from 0 to 100. You can go from 0 to a 10. What perhaps might be the first decision that we should be thinking about? What are some low-hanging fruits that hopefully with the data that you have, with models that perhaps might be even off the shelf, I can make a change that is quantifiable? I think the more you question, the more critical you are, it will be much better in terms of planning, and it will be much better in terms of ROI. So getting some familiarity with the business questions and getting some familiarity with what happens within the black box will become much easier to understand what are the strengths and limitations of these. Now, I think it's much easier to see machine learning if we sort of categorize the typical machine learning models. So in the columns, there are two words that are being used, supervised and unsupervised, which I'll tell you in a second what that is. In the rows is what exactly is the outcome that you're trying to predict. So let's take the top left row, which is discrete and supervised. So what is the idea of supervised learning? It's a very common term that's out there. Supervised learning basically refers to a type of machine learning model in which there is something, a dependent variable, so to speak, that you're trying to predict. So if you're talking about a discrete dependent variable, which is the top left corner, it might be customer churn, let's say. Does the customer stay with you or leave? So 0 or 1. And if that's the case, how do you kind of look at that particular prediction as a bunch of all different data that you might have in the past? So supervised learning is a type of learning where we are trying to learn the relationship between dependent variable, a Y variable, an outcome variable that you're trying to learn, and a bunch of independent variables that you might have within your company. Okay? So that's what supervised learning is all about. The outcome could either be discrete, which is in this case customer churn. It could be continuous, in this case sales forecasting. Unsupervised learning on the right hand side is basically a situation in which you're trying to learn the relationship only among the X variables, the independent variables. The most common example there is customer segmentation, where what we're trying to learn is which customers are similar and are there different models that can be used to learn how customers can be segmented. Let me quickly give you some examples and then focus on one particular example. So supervised learning, let me just lay this out because I'm just literally summarizing what I just said, which is in supervised learning, there's a Y, an output variable. There are a bunch of X variables, the input variable. Now you're trying to learn the relationship between Y and X's. That's the mapping, the F function that you can call it. What's the idea of machine learning? The idea of machine learning is, if you want to put it that way, it's like regression on steroids. Now, what does that mean? What that means is, in the real world, there is a lot of non-linearity that might be going on. So for instance, for those of us who may have seen, for example, let's say real estate prices. So Zillow is a common example here in the US. There are many other companies that give you real estate prices, for example, in other parts of the world. And you look at house prices and you're trying to figure out, like, why are the prices the way they are? Now, that's a very, very, very difficult and kind of sort of complex question. Why? Because the house prices might be dependent on so many different factors. What are the house prices around you? What are the school district like? All the other, perhaps crime rates and so on. And secondly, those relationships might be highly nonlinear, highly interactive. And so that's where I think machine learning works very, very well. When you have a lot of variables, a lot of data, and you're trying to learn the relationship among these variables and try to predict a particular outcome. So that's what is called as supervised learning. Again, you'll notice I've highlighted training and test in red. That's a very common term that is used. Training data is, again, the data that's used for calibrating the model. Test data is where you quote unquote test the model. Now, what is unsupervised learning? Just a very quick one. Is where there is no outcome variable at all. There are only lots of input variables, the X's. The most common example there is segmentation, where the idea is you have a bunch of variables, demographics, psychographics, lots of other variables perhaps for your customers. Of course, it doesn't have to be B2C. It can be B2B as well. And what you're trying to figure out is, are there segments? in this particular database. So it's less about the dependent variable Y. There's nothing to predict per se. What you're trying to uncover is which sets of customers are similar in nature. So that's the most common example of unsupervised learning. Let me give you a quick example in terms of the models that are used in a second, but I just want to kind of lay this out. When you think about machine learning, there is a plethora of models out there. Decision trees, bagging, boosting, random forest. At the end of the day, I think, yes, devil is in the details. But what's more important, I guess, is what are the strengths and limitations of the different models and what purpose is it being used for? So I think thinking about which model perhaps is good for your application and why you want to use it, I think that's very important. But also understanding that some of these models perhaps might give you results that are closer to each other. In which case, I think explainability of those results also plays a big role. Which one do you want to choose? Why do you want to choose it? I think this is where I think the analysts, the data scientists that you may have within your company, they can perhaps do a very good job of figuring out which model to use. But at the same time, I think what's very important is keep the business question in mind. Is there synergy between the business question and the way you're applying that particular model? A quick example from some of my own research. I was very interested, and I still am. So if there are people out there who work on subscription programs, please contact me. So I worked very closely with a company that was coming out with a subscription program, and obviously they were very interested in figuring out subscription programs, does it lead to profits at the end? Okay? So clearly a very important question for all the companies that are in this particular kind of business. Now, let's take a quick example. So if you think about Amazon Prime as an example of a subscription program, on the one hand, you might say, well, what's the problem? Let's just compare people who have Prime with the people who don't have Prime, make that comparison, and we are good to go. But the problem, of course, is that you might make that comparison, but what are you missing out on? Is it really the program that's impacting it, or is it the people that are impacting it, which is the type of people who take a subscription program, in this case, Amazon Prime, and the type of people who don't might actually be different. And so it's directly comparing just simply subscribers and non-subscribers, or members and non-members, might be like comparing apples to oranges. So how can we avoid that? So that was the basic story. Now here's where a machine learning model came in, where we wanted to basically compare members and non-members to control for this selection problem, which is members don't become members by chance. They're obviously selecting into the program. So how do we make that comparison? And what was interesting was that there are many, many, many variables, hundreds in fact, that this company had, all kinds of historical information. That was the big hurdle, that you really can't simply just make a comparison because there's so many variables out there. That's what made, for example, a random forest, which is like a collection of trees in some sense, become the kind of appropriate model that we ended up using in this comparison. So I'll give you a quick example. So for instance, what are we trying to do? We're trying to find lookalikes. For every person who became a member, let me find a non-member which is very similar, as similar as possible on all of these variables as much as possible before they became members. And then when we have found the lookalikes, the doppelgangers, we can then compare what happens to their behavior after they become members. Okay? So for instance, for every Ryan Gosling, this is a famous actor who's a member, you might end up finding this person who's a non-member. Well, kind of looks similar. You got to stretch your eyes a little bit. Ryan Gosling might be great in Hollywood. The non-member might be good in Bollywood. So, but more to the point, you might find somebody like this who happens to be an accountant in Germany. So you can find lookalikes. So that's where that model became very helpful, and we could go ahead and see what is the impact of subscriptions on profits. So if somebody's interested, we had a little write-up in HBR recently, so please reach out. Happy to share that as well. All right. Having said that, I think what's also becoming important and something to very carefully think about is what are called data-centric AI. So Andrew Ng, who is a very big name in this area, he's the co-founder of Coursera, has been talking a lot about the fact that in this day and age, on the one hand, we've had lots and lots of sophistication in models, lots of models. And the slide I was showing you before kind of told you how these models are changing and different. What he's very much interested now is in revolution of the same kind in data quality. So rather than simply making the models more and more sophisticated, if the data itself is not good quality, obviously no model can do that. And in fact, many businesses unfortunately can make mistakes. Let me give you an example. So one thing that has become very, very important nowadays is thinking very carefully about how inclusive the training data is. What's an example of that? There was a very nice documentary on Netflix. This was a few months ago, if I remember right, called Coded Bias. And the story was that the person on the left, she was a grad student in media labs in MIT. And she was trying to figure out how do these facial recognition software work. What did she find? What she found was that no matter what the company, so this was not company specific, no matter what the company was, Amazon, Google, whatever the company was, that facial recognition software unfortunately was not able to recognize darker color skin. Now, why would that happen? Well, it's not fault of the software per se, it's the fault of the data on which it was trained. So understanding, for example, how reliable the data is, how inclusive the data is, that becomes very, very important. And so there are many headlines, of course, of this kind, where the best algorithms struggle to recognize black faces equally. So you can imagine, obviously, it created a lot of controversy. Many companies like Google actually responded to this, kind of saying that they have now expanded the set of faces on which their model is trained on. So thinking carefully about how good your data is, how reliable the data is, how inclusive the data is, becomes very, very important as you're applying these. Next one is the frequency of updates, which is how much can you rely on historical data? Obviously, the last 2.5 years or so have really been a seismic shift in terms of customer behavior. Pre-COVID and post-COVID, the customer itself has changed. Their journeys have changed. So clearly, using the models that were from February 2020 and before may not be as applicable. So understanding how much can you rely on that data, how often your data is getting updated, and of course, thinking from a customer perspective, what is the customer behavior like? How much of it is sticky and what parts are changing? I think, again, the big picture I wanted to get across here was, and I'll give you some more examples as we go forward from a customer journey perspective. The big picture is, yes, there is a lot of value of machine learning. There's a lot of value of AI and all those wonderful things. But think critically about how good your data is. Think critically about the business problem and the business decisions, and then go ahead and start thinking about the value of embracing those new technologies. Now, very quickly, I just want to talk briefly about the digital strategy. Many of the companies that I've been talking to have clearly seen a shift from a customer journey perspective from quote unquote offline to online and now omni-channel, so to speak. Now, clearly, you think about what kinds of technology, what kinds of new types of data are coming in, and how would we, in some sense, analyze that data and get some insights out of it. Okay? So when we think about that setup, there is a lot of information out there. AI by industry, you see a lot of kind of stories around how it's shaking up the banking industry, the retail industry, the industry where, the pharmaceutical industry, and so on. Lots of action there. You could also start thinking about it from a purpose point of view. Voice AI, being Google or Amazon Echo, Vision AI, lots of companies perhaps now are thinking about how can you come up with digital fitting rooms and so on. And also text AI, GPT-3, again, if you haven't heard of it, if you just Google it, you will see it. There are lots and lots of new technologies which are allowing machines, so to speak, to write entire articles. And so you can think of it from a purpose point of view. What is exactly the purpose it's serving? So many times when you think about AI, of course, there are many failures as well, just as an example. Now, many companies are kind of struggling with exactly when is it that they should be using some of these models and when is it that perhaps human interaction is more valuable. So one question that many companies sometimes ask is, how can we unleash the power of machine intelligence? I think that's an important question. But to me, perhaps a more relevant question is, what do you know about your customer journey? And where exactly can these types of new models and new data and new analysis help you better understand the customer journey? So, for instance, when you think about the typical path to purchase, that's what we've been told. The awareness, you have some interest, consideration, You look at what brands you want to buy and so on and so forth. When you think about this type of customer journey and contrast it to something which looks like this, which is an Airbnb, just as an example, what do you notice? Typically, when you're trying to book a hotel room through Airbnb or whatever the case might be, what you typically see is a lot of back and forth. You start looking at dates, you look at a particular place, you say, well, this is good, but the place I really wanted is unfortunately booked. You go back, perhaps change the dates, go back in again, something else opens up, lots of back and forth. Why do I bring this up? The reason I bring this up is that this linear path to purchase, awareness, interest, consideration, all that stuff is perhaps no longer applicable as much. Why? Because of these new technologies. And I think as journeys become a lot more non-linear, as journeys become different from one customer segment to the other, I think what we have to think about is how can these new technologies, AI, ML, big data that we've been collecting, how can they help us in some sense understand that journey better? Okay, so an even more relevant question is, can you use ML and AI to learn about the customer journey? Quick examples. So one is you can use new technologies to better predict, of course, the customer journey. Another could be you can make the journey shorter. Let's take the first one, better predict customer journey. This is sort of this very standard recommendation system that we've all heard of. Be it the Netflix, be it Stitch Fix, be it Amazon, they look at historical data and make predictions about what next might a customer buy, and in some sense help make that journey better and facilitate that journey. So that's one example of predicting the customer journey, how you can use new models to perhaps help that particular prediction. Another could be making the journey shorter. So these are examples where you might use virtual kind of fitting rooms. You can use different kinds of apps which can help you figure out, from the time of awareness of the need to actual purchase, how can they make the journey shorter? So that's another example. I think a third thing to think about, of course, is can you in some sense move upstream in the customer journey? So a quick example of that might be something like this, where many of us, when we think about product searches, for instance, when you think about searching, Google typically comes to mind. But here's an example. This is from a year ago or so, where do people, or in this case, the US adults, begin their product search when they're purchasing products? It's Amazon. And what's interesting is these numbers are even more inflated for Amazon Prime members. So you can imagine the power that Amazon has in sense of curating the customer journey, understanding how much of the customer journey and what people are looking for, and how can you use data, machine learning, all the analyses that we've been talking about in terms of doing that curation. So to me, perhaps an even bigger question is how much of your customer journey do you own, and how can you use ML, AI, and all the data that you're collecting to own more of that customer. Very last thing, I think, as we wrap things up and I'll open up for questions, is when you start thinking about ML and AI, I think what's also important beyond the technology, beyond all the data you're collecting, is just the organizational structure and how can you implement some of these practices within your organization to have as much impact as possible. So typically what you've seen is, having a very diverse point of view, sort of having a brain trust, you can call it an AI brain trust, or basically people who are from different parts of the organization, and sometimes perhaps even outside the organization, who can help you understand what are the kinds of questions that perhaps can be best handled by machine learning, what are the kinds of business questions that perhaps need a human interface, and then starting to think about what are the short-term initiatives, the low-hanging fruit, and what is the long-term strategic vision. Taking some of these machine learning portfolio projects or business decisions and kind of having 4 or 5 short-term projects which are the low-hanging fruit, one long-term project which gives you the strategic vision, and then figuring out exactly how the organization should be set up around that particular initiative. I think when you think about ML, AI, and all the things that are becoming very, very important, I think one thing that I would say is thinking about the right idea. I don't think there's any substitute. There are no models out there which are substitute for good thinking. So thinking about the right idea, thinking about the business problem, and then starting to go and start looking at data assets and all the other details which are very important. But in the midst of the details, one shouldn't forget about the big picture. And as Confucius said, I don't know whether he was being prescient when he thought about this. Maybe he was thinking about machine learning. Is don't use a cannon to kill a fly. In many, many cases, machine learning can be an answer, but you might get a lot of the way by just careful thinking and good data collection. So yes, one can embrace machine learning, but have some healthy skepticism. Be very careful in terms of what the problem is, and then once you see the match, go ahead and embrace it. That's my contact information. I'll stop here and I'll open it up for questions, but I would love to be connected. We'll have all the questions now, but if you have other things that you want to chat about, I am quite active on LinkedIn. Please feel free to connect with me. So Sarah, maybe I'll pass it over to you for any questions, comments, anything that you may have.
Awesome. Thank you so much, Raghu. That was so enlightening and very, very fascinating. So we do have some questions coming in from folks. So question number one, can you please discuss the ethical issues raised by this captured data from customers/public? Do they need to agree to provide their information?
I think this is a very important question that's obviously quite relevant across a variety of different kind of domains. So you can imagine, for example, things like facial recognition. When you're going out in public, are you in some sense agreeing for your data to be captured? And implicitly, I guess you are if you're walking out there. And I think there was a very big debate going on especially in the UK, where there are lots of cameras and people are being captured all the time. And so there was in the same documentary that I was mentioning earlier, there was a big debate about, whether that is kosher per se, how much of it should have, in some sense, a buy-in from customers, so to speak. I think what I suggest is thinking carefully about, again, what you're collecting, why you're collecting, as much as possible. I think what has also happened is because of GDPR, CCPA, which is the California Privacy Act, all of these, I think, on the one hand, you might say have made it more burdensome for companies, but I would take the more positive route, which is I think they are putting the onus on companies to think carefully about, is that data really necessary? And if so, can we make sure that consumers understand what are they getting in return for that data? So making it as kind of clear as possible that these are the benefits that you're getting as a consumer when you give us that particular data. But I think those are very important questions to be answered, absolutely.
And Raghu, can you delve into any examples, sort of cautionary tales about misuse of this, data being collected?
Absolutely. So there was a company called Strava. This is a company where you can think of it as a website/community for super active people. It's like a LinkedIn for super active people. So what does this company do? Let's imagine you may have a Fitbit, Apple Watch, whatever the case might be. You're super active. You perhaps want to share that data with your friends. Sometimes people like to compete all the time. Did you have the 10,000 steps or 20,000 or 200,000, whatever the case might be. And so you upload that information. And Strava, this was about a few years ago, 2017 or 18, if I remember right, they decided to take that information, again, all anonymized, and kind of reveal how much amazing information they have in terms of all the activity that's going on. So that also sounds good because of anonymity again. But somebody decided, why don't we take that data and superimpose Google Maps on top of it? Now, what happened? Well, unfortunately, there were lots and lots of headlines saying Strava and the end of secrets. Why? Because there were people actually from the US Army in Afghanistan that were actually uploading that information. And so, unfortunately, when you end up on the front page of New York Times for all the wrong reasons, that's not good news.
Definitely not a good thing to do. I'm sure the military were not happy about that.
Absolutely.
So switching from marketing and using machine learning for marketing to people analytics, do you have any thoughts about using AI to improve employee productivity? For example, tracking their health, tracking their output. Obviously, we need to be aware of the privacy implications, but I wonder if you have other insights for how such tracking can be helpful.
Yeah. So actually, when you think about, I was giving the example of Fitbit. If you think about Fitbit, actually, and if you go on their website now, they're rapidly moving from a B2C company to a B2B company, which is they're actually cooperating a lot with organizations who want their employees to be healthy. And the idea there is that, as you provide incentives to employees for wellness programs, it could be like Penn, for example, has very nice wellness programs for all of us who are employees of Penn. Or you may have, for example, some other kind of activity related programs. What you also want to see from a company's point of view, and not perhaps at the individual level, but at least at an aggregate level, are employees, for example, who are participating in those programs actually showing healthy returns. And so from a financial perspective, obviously that becomes important, but also from just the mindset perspective of employees per se. Are people perhaps more positive? Are people enjoying, quote unquote, working? And at the same time, from a methodological perspective, actually there are lots and lots of algorithms nowadays, which are called differential privacy algorithms. Apple uses it, where the idea is that when you're collecting data from a company's perspective, you typically, quote unquote, jiggle the actual number a little bit. So add some random noise. And the idea is that when you collect that information, you're getting the overall trends, but you don't know exactly where that information is coming from, which is that person. So there are ways around it now where you can get individual level information, but yet hopefully avoid targeting that person at the individual level.
Excellent. So moving on to the next question, many e-commerce companies use recommendation engines to show customers relevant products at different points in the shopping journey. Other people like this, similar products frequently bought together. How do companies determine which recommendation engine to use and where? Are any companies or people thinking about a recommendation engine of which recommendation engine to use and where?
Yeah, and I think, on the one hand, again, perhaps from my perspective, at some point, many of these recommendation systems can fall into two blocks. One is what I call content filtering. Another is collaborative filtering. Content filtering is kind of looking at the content, looking at the characteristics. Think about Netflix, you're looking at different movies. Another is collaborative, which is, looking across people. So if I am similar to somebody else, if that person likes something, perhaps I would like it as well. No, and there might be some combination of the two. I think what's more important is perhaps when you start thinking about recommendation engines, yes, there is some sort of maturity in terms of what these recommendation engines do. But I think the critical issue is what they call the cold start problem, which is what do you do when you have no data, and you're starting to implement recommendation engines? Like, what do you rely on? And I think there are a lot more companies that are now collecting data which can help you train your models. So that's kind of the spirit of data-centric AI, rather than starting from scratch, starting from a complete whiteboard. How can we use some of the data that people may have collected, train our models, and then start assessing it? So I don't have an answer per se, what is the best recommendation engine out there, but I think thinking about how it uses the data that you may have, is it collaborative? Is it more sort of content? Is it some combination? And what is it especially doing as you get started when you don't have historical data? And that's where some of those hurdles can happen.
Awesome. And that's a good segue really to this next question, which is really going back to, step one. How can you start thinking about machine learning if you are a new company and do not have your own data yet?
No, great question. I think the good news, I guess, in some sense is what has happened in the last, I would say, 10, 15 years is democratization of machine learning, very broadly. Democratization meaning that, in terms of models, you can Google Cloud, for example, or the AWS servers, they're not just places where you can store data, they actually have a lot of built-in machinery where you can analyze that data. So that's number one, where you don't have to do in-house development of models. On the flip side, there are many companies out there that are, quote unquote, becoming data repositories. So Kaggle, for example, where you have all these datathons and all that stuff that's going on. I mean, you can think of it as a data repository, where you have lots of data out there that people have put up. There's another company called Data.World, which also is an open source sort of data repository. So I think that's where I think the hurdle of I don't have my own data, what do I do? I think that's where that hurdle is also getting reduced. Of course, if you have a very specific application, you have to collect your own data. But I think if you think about, things like image recognition, things like sound recognition, and things of that nature, there are a lot more data repositories out there that you can train these models.
Excellent. The next question really builds beautifully on the previous two. What practical steps would you recommend taking to improve the quality of data?
Great point. So I think what I would do is, when you start thinking about using a machine learning model on your data before you run the model, and that's something I think we will talk a little bit more about when we talk about the wonderful work that we've done together in Wharton Interactive. Like before you run the models, kind of quote unquote get familiar with the data. Uh, it might be as easy as visualizing the data. If there are certain, for example, I'll just give you a concrete example. If you're thinking about, let's say, retail across the US or whatever geography you may have, uh, kind of seeing where are all these retail kind of sales coming from? Are they equally distributed? Are there some things which are perhaps more represented than others? And so if you now take away the spatial context and perhaps put in race or gender, becomes quite important. If are substantial of your sales perhaps coming from males versus females, or what is the gender distribution? So I think kind of getting familiar with what the distribution of the data is like, and in some sense, does it conform to the intuition that you may have? So before you run the models, I think that step becomes quite critical.
Phenomenal. And that is going to be a great segue into when I start showing the incredible game that we've built together. We have two more questions here. So the next question is, can you recap or illustrate erroneous findings or applications of AI?
Yeah. So there are many, unfortunately, as you can imagine, and as many companies are taking this on. And again, I don't want to say that these companies are doing something wrong. I mean, testing and learning. I mean, that's unfortunately or fortunately, that's the way things go on. So as an example, a quick one, just to kind of make maybe mindful of the time. Amazon, for instance, again, I don't want to beat down on Amazon. It's a big company, and big companies sometimes have failures. So Amazon, for example, had recently, a few years ago, decided that they would like to automate their recruiting process, in the sense that, let's say if Raghu Iyengar wants to become a software engineer at Amazon, he might decide to send his resume. And obviously there might be human in the loop, but there are hundreds and thousands of people submitting their resumes. So Amazon decided, why don't we start looking at these resumes and automate a model that can parse through the resume and at least make a good guess for whether this is a person that might succeed as that software engineer. Now the question is, what data do you use to train that model? Well, they looked at the current software engineers that they had, and they were looking at the resumes that they had sent in and what their success or failure had been within the company. Great, the model got trained and it started being deployed. What was the problem? The problem was that after they started looking at who were the people that were bubbling up versus who were the people that were being rejected, unfortunately, a lot of women were being rejected. Why? Because the current software engineers were predominantly male. And so the model did not pick up, in some sense, that the gender could be a huge biasing factor. And so I think thinking, again, going back to the previous question, thinking about kind of the distribution of your data, thinking about how representative that data is, and when you apply it, for instance, is it kind of conforming to what you would expect to happen, so on, becomes quite critical.
That's amazing. And that actually answers the next question really well. And since I just said that, two more questions just popped up. So we're going to just quickly try to answer at least one of them. Do you have any examples of software tools that can be readily used for data policing to reduce data biasing and data manipulation?
Great point. Actually, many companies, like Google as an example, has a good, again, Google is just one name, has a good suite of software where you can kind of come in, look at the data, and kind of see whether they're falling into those categories or not. And I think it's very timely because from what I've heard when I talk to my lawyer friends, yes, I do have lawyer friends, even though marketers might not like lawyers, but I think lawyers think long term. But when I talk to my lawyer friends, they basically say that there are a lot more regulation that's coming around, especially around AI and human resources, to kind of HR, so to speak, which is as more and more companies start deploying algorithms, models to help with their recruiting and even retention. Obviously, there are a lot more biases that might surface up. And why? Because the models that are being done are on data that may be biased, or people themselves are biased that are building those models. So I think thinking about that interplay becomes important. So I think just kind of starting with Google as an example, but perhaps looking at other companies that are diving into HR per se might be very helpful.
Great. And Raghu, just one last question because it builds beautifully on this, and then I'm going to switch to talking about the machine learning game that we've built. Is it getting easier to collect and store large volumes of data on the behavior of people? What are the risks of being hacked and the data showing up on the dark web?
Yeah, no, I think thinking carefully about sort of either data hacking or inadvertently data being used for purposes that were not similar to what was collected for. I think that perhaps can happen as well, where you collect the data in one context, and other data scientists come along and they're using that data for a completely different context. I think to me, what is quite important, and I think this is where my lawyer joke perhaps might come in, which is thinking carefully about each column and understanding the objective of that column. Now, do you really need it? And sort of forecasting ahead, what regulations might be coming where that column may not be used anymore. And so kind of it puts a bigger onus on just using that data within the company. But I think sort of this additional skepticism, additional caution, I think will really have big dividends as we move forward.
Phenomenal, Raghu. Thank you so much. So I know you're going to stay on screen here while I talk about the incredible work that you've been doing in the customer analytics. And by the way, analytics at Wharton have been an incredible partner of Wharton Interactive's. So as I mentioned at the top of the hour, we are working at Wharton Interactive at thinking about the future of learning. We're thinking about making deeply immersive experiences where learners can actually roll up their sleeves and do the work that we are talking about here in Wharton Classroom. So when Raghu is teaching us about machine learning, we now have a game where you can step in, even if you've never written a line of Python code in your life, all the lessons that Raghu has been talking about in this last hour come to life in this game. So thinking about exploratory data analysis, where is their bias? Where is the missing information? Where are there gaps in your data? We're going to take you through exactly what that looks like. And you've got non-player characters within the game who are really going to be testing and supporting you every step of the way. How do you test and train a model? So what we now have is we have a gaming platform that the Wharton School has built from the ground up, and we have integration with real code, and Evite have given us actually millions of lines of real customer data that we've created into this fictitious narrative. So I'm going to just step in and just give you a quick demo. And what we're going to do is, for the second webinar, we're going to ask you all to go and play this game. It's available on Wharton Interactive. Let me just share my screen here. So if you go to interactive.wharton.upenn.edu and click on Play with the World, you will find the Machine Learning for Business Decisions. It is an on-demand game. It's usually $99, but we're going to be providing it for a very, very low discount of $12 for each of our wonderful alumni. And you can just register and play it on your own. And once you register, you're going to be brought into this gaming environment where, as I mentioned, you're going to be taking meetings with non-player characters who are going to set up the context of the story and the challenges. You're going to have Priya here in the game who's going to be taking you every step of the way through the experience. Dashboards with information are going to open up. And I'm just going to really quickly play the opening scene to kind of set the scene of the game for you.
Okay, look, I know it's never a good sign when your CEO calls you out of the blue, and from the company chopper, no less. But I wouldn't do this without a reason. You've been a superstar on every project we put you on at Symmetry. I'm headed over to Evite's headquarters in LA to close a big deal, and I found out that, well, Bob messed up again. Yes, that Bob. To land this data analytics project, I need 3 important things to finish my presentation. First, how confident are we in our ability to leverage machine learning to make predictions for Evite? Second, how well did our test models perform? And third, the business justification and thinking behind how we built our models. Obviously, I can't trust Bob with this again, which is why I'm calling you. I know you haven't worked on the Evite project before, but Priya's offered to give you a crash course on the data analytics so you can fill in the gaps before I arrive at Evite in about an hour. But I know you can do it, and Priya's got your back. Oh, and tell Bob that...
All right, so off she goes. And then what's really phenomenal about this, it's a closed environment within this gaming platform. And we actually have lectures that have been taped by Raghu, and new lectures open up each step of the way, providing you with just-in-time lessons. We also provide everything you need to know with respect to the coding and the analytics that you're going to be running, as well as really incredible lessons coming from Victor Cho as well, who is the former CEO and now on the board of directors for eVite. And then the last but not least, you're stepping into a Jupyter notebook that is all your own. And this is where the code and the algorithms and the exploratory data analysis and all of this opens up to you. And by the end of this game, you will have run 3 XGBoost algorithms. You will have tuned them, you will have analyzed them, and you will be providing your recommendations to Jacqueline when she lands at eVite in 1 to 2 hours. And she does run into some turbulence. You do have a few hours to finish the game. And you can see the Find My CEO right here. So we really do hope that you'll come and play the game. And then what we would like to do is in a few weeks' time, come back together. And Raghu and me and a few members of my team are going to go through the experience that you had, which is actually all these lessons that Raghu mentioned today, and how did you apply them, and where did you run into issues and questions, and you can ask the master himself. So we hope to see you in the game.
Yeah, no, I think I'll just add, I think for those of us who are attending, one of the big hurdles for perhaps somebody who wants to get into machine learning, or at least just want some experience, is the fact that the data sometimes is one place. Then you have these software things, you're not exactly sure what to do. Then you're talking about Jupyter Notebook. How does this all come together? Where are things stored? So I think what Wharton Interactive has done is put everything together to make your journey seamless. And I think that's as, perhaps an easy an environment as you can get in terms of understanding machine learning and seeing the use.
Wonderful. So Raghu, thank you so much for this amazing information and lesson. I'm going to turn it over to Alyssa to take us out.
Thank you so much, Raghu and Sarah, for today's session, and to all of our alumni for joining us. A feedback survey is available on the top of the video player. This webinar has been recorded and will be available on our event video library in the coming days. We hope you will register for and take the Machine Learning for Business Decisions course over the next few weeks, and come again and join Sarah, Raghu, and her team for an informal Q&A session on June 21st at 12 p.m. Eastern Time. Questions about either offering can be sent to lifelonglearning@wharton.upenn.edu. Now I'll turn it back to you, Raghu and Sarah, for any final thoughts.
Sarah, please, go for it.
Yeah, I just wanted to thank everybody for coming and for the opportunity to be involved with lifelong learning on this webinar. Thank you so much, everybody.
Thank you, everybody. And check out all the wonderful things that Wharton Interactive is doing on other areas as well. So if you go there, you'll see lots of other things. Thank you.